Synthetic division is a shortcut for dividing polynomials when the divisor is in the linear form mx plus b. To determine the number c used in the division, we set our divisor x plus 2 equals to 0 and solve for x. So we're going to subtract 2 on both sides here. Therefore, x equals to negative 2. And that's the value of c, which is placed in the backward L of synthetic division. Next, we are going to list the coefficients of the dividend, which is the polynomial being divided, in descending order of exponents. So the highest exponent here is 4, so we are going to write down the coefficient for the x to the 4th term, which is 2. And the next term should be x to the 3rd power, so it's missing that exponent. So you're going to add 0 as the placeholder to maintain the alignment. And the next coefficient is going to be negative 3. And then the x term, the coefficient is 14. And then the constant is 14. In synthetic division, you bring down your leading coefficient, which is 2. And numbers below the line, you're going to multiply by the c value, negative 2. And the numbers above the line, you're going to add them together. So we're going to start with our first number below the line, 2, and then multiply by negative 2. That will give us negative 4. And then you're going to add negative 4 and 0, which is negative 4. Then multiply negative 4 by the c value, negative 2, which will give us 8. And then add 8 and negative 3, which is 5. Multiply 5 by negative 2, which is negative 10. And add negative 10 and 14, that will give us 4. Multiply 4 by negative 2, so that will be negative 8. And add 14 and negative 8. So that's going to be 6. The last number below the line is the remainder. The rest of the numbers will be the coefficients for the quotient. So working backward from the remainder, the previous number is going to be the constant term, and the next one will be the x term, x squared term, and x to the 3rd power term. So the final answer for this problem is going to be 2x to the 3rd power minus 4x squared plus 5x plus the constant, and then plus the remainder 6 over the divisor, which is x plus 2. Since our divisor here is also in the form of mx plus b, we know we can divide these polynomials using synthetic division. Our first step again is to find the value of c by setting our divisor 2x plus 3 equals to 0. And then we're going to solve for x by subtracting 3 on both sides. So 2x is going to equal to negative 3 and then divided by 2. So x equals to negative 3 over 2. And that's the value that's going to go into the backward L of synthetic division. The next step is to list the coefficients of the dividend, which is the polynomial being divided in descending order of exponents. So our leading coefficient here is going to be 4 because the highest exponent here is x to the 4th power. And then our next coefficient for x to the 3rd term is negative 6. And it's missing the x squared term, so you're going to add 0 as the placeholder. And the next term will be the x term with a coefficient of 5. And then we have constant of negative 7. So in synthetic division, you always bring down your leading coefficient, which is 4. And the numbers below the line, you're going to multiply by negative 3 over 2. And the numbers above the line, you're going to add them together. So 4 times negative 3 over 2 is negative 6. And then you're going to add negative 6 plus another negative 6. That will give us negative 12. and multiply negative 12 by negative 3 over 2, that's 18. 0 plus 18 is 18. And then multiply that value by negative 3 over 2 again, and that will give us negative 27. And then you add that value to 5, which is negative 22. Multiply negative 22 by negative 3 over 2, that will give us 33. And add 33 and negative 7, that will give us the remainder, which is 26. The rest of the numbers will be the coefficients of the quotient. Now this time our coefficients can be reduced by 2 because all those numbers are divisible by 2. So therefore, when I divide each one of these numbers by 2, it's going to give us negative 11 here, 9 here, negative 6 here, and then 2 here. So now going backwards, we know that the number before the remainder is going to be our constant, and this will be the x term, x squared term, and this is x to the third term. So our final answer is going to be 2x to the third power minus 6x squared plus 9x minus 11, the constant, and then plus the remainder, which is 26 over the divisor, 2x plus 3. The reason we don't divide the remainder by 2 because the remainder is not part of the main division process. It represents what's left after the division. So that's why we're only reducing the coefficients of the quotient by 2, not the remainder.